Hello everyone. I think remember in the last session we did the psychrometric chart and the properties of air. So in today's session, let me continue with the psychrometric process because this is also important at the time of load calculation. So we have a different psychrometric process like a heating, sensible heating process or the cooling process or the dehumidification process or humidification process or evaporative cooling process or mixed air process. So we have different types of process that will verify on the psychrometric chart, which is very basic and very important. We'll use this at the time of load calculation under the psychrometric analysis, because the psychrometric analysis will deal at the time of load calculation to find out the properties of air at different condition, like supply air, return air, mixed air, fresh air, etc. So this the knowledge of understanding this processes for different conditions is very basic and hard for an HVAC design engineer, especially for the load calculation point of view. So we'll discuss in detail about the different process. And at the end of this chapter 4, we'll deal with the equations for sensible, latent, and the total. Again, that equations also will use at the time of heat gain through ventilation, heat gain through infiltration at the time of load calculation for sensible and for latent. So this topic is very basic and at the same time very important. And some more topics related to psychrometry like bypass factor, contact factor, and psychrometric analysis that we'll discuss in between the load calculation. Except that in that properties remaining, I'll complete all in chapter 4 only. So I'm going to share the screen. So here you see, understanding psychrometric allows the designer what property of air must be changed to achieve the desired properties as per the comfort requirement. And you see, understanding this required processes is the heart of HVAC system design. So what are the different process? You'll find the list here, and each and every process will verify with the help of the psychrometric chart. So you can find the different process. First in the list is a heating process, or in other words, I can say sensible heating process. Next is a cooling process. Cooling process means it's not completely sensible, partly latent. How exactly? I'll show you. Don't worry. Next, dehumidification process. And dehumidification process can be with the separate dehumidifier or with the cooling coil with the reheat option. How exactly? I'll show you. Next, isothermal humidification process. As a mechanical, isothermal means constant temperature, right? Isothermal means refers to the constant temperature. No? So humidification process at constant temperature. Similarly, adiabatic humidity process or humidification process. Adiabatic refers to what? You see, isothermal is a constant temperature. Similarly, adiabatic refers to constant enthalpy process. Means there is no change in the heat or internal energy. So this is constant temperature and this is constant enthalpy, adiabatic humidification process. So both is humidification process, but with the different ways. Next, evaporative cooling process for sensible cooling, especially for the desert areas. Next, mixing air stream process means we'll try to understand the condition of the mixed air. Mixed air means I'm referring to the fresh air with the return air. So in actual practice, we are introducing some amount of fresh air to the return air, and you'll get the mixed air in the return air plenum or in the return air plenum box, a box which is connected at the suction side of the unit that we used to call return air plenum. That we'll discuss at the time await site. At this level, just mixing process. So mixing process with respect to the return and the fresh air. So what will be the condition for the mix air in case if I use 50% fresh air or say 30% fresh air, etc. Next, sensible air to air recovery and enthalpy energy recovery. Last 2 points is related to this ventilation reclaim or HRU, heat recovery unit. Okay, so that we'll discuss at the time of app. The last 2 points remaining I'm going to cover now in this chapter 4 only. Okay, so let me expand this process step by step. The first process, you see, at this level you may not get the complete idea for this, but understanding this process will help at the time of load calculation, especially at the time of psychrometric analysis. So I request to please focus on this topic because this is very, very basic for an HVAC design engineer. So it's very easy, you can understand. So you see the first process is a heating process. So first of all, how we can provide the heat? There are different ways to provide the heat to the air. One can use the electric heaters, normally like small room heaters, or else I can use the hot water from the boiler, or else I can use the heat pump refrigerant coils, nothing but the same vapor compression cycle work in a reverse cycle. So different ways to provide the heating to the air. That we'll discuss later at the time of classification of machine in detail. At this level, just remember, we can provide the air by using the hot water or by using electric heaters, nothing but this portable room heaters, or one can use this heat pump refrigerant cycle. Okay.
So in practice, what
Mhm.
system is in practice? What system is uses?
You see, for central cooling plus heating, you see central cooling plus partly heating, we are using electric heaters. Okay.
Okay.
But for central heating plus partly cooling, in that case, for central heating, we are using boilers. Okay. And this heat pump now in market with the VRF system. So more about this system you'll find in chapter 5 with more details with detailed classification. At this level, just ignore this how we can provide, but how this process on psychrometric chart, this theoretical process at this level is important so that you can understand all this at the in the practical side when we deal with the systems. So we can visualize how the process of air, what will be the conditions of air at different process. Okay, so that understanding is very, very important. So at this level, just focus on this process particularly. Means heating process means just heating. Don't mix the cooling or other dehumidification or humidification part by part. So the first option on screen is a heating process, or in other words, I can say sensible heating. Okay, because we are not adding or we are not increasing this humidity. So how exactly? So let me explain or let me expand this. So on screen, you can find this I'm considering say 0.1 and this I'm considering as 0.2. So you see this 0.1, the temperature of air, just I'm considering say 32 degree Fahrenheit. For example, you see this is example. You can take with any two examples. Okay, so 32 degree Fahrenheit, nothing but the freezing point of water. No? But in this case, don't get confused. I'm talking about the air. Okay, so water is different, air is different. So here 32 degree Fahrenheit means say 0 degree. Just you can assume the temperature of air at 0 degree centigrade, nothing but 32 degree Fahrenheit. Okay, so it's air in air only, it will not freeze. So starting point 0.1 is 32 degree Fahrenheit, and I'm going to add the heat, and I'm looking for end result at what 75 degree Fahrenheit. This is my requirement. So you can see on the psychrometric chart, going in the state path from left to right is what? You know this already we discussed in the previous session.
Driver
This
temperature increase.
so you see this scale increase in horizontal, and you'll find in the vertical orientation that lines, but increase in horizontal that increase to the dry bulb. Okay, so you see increase in dry bulb, but what about the other condition? So let me write the condition first. If you want, you can please make a note of this. You can write heating process in the notes. Just write down this points. All this notes you'll get. Don't worry, but this point is not in the notes, so that will help you. So the first condition is the drivable temperature. So drivable temperature, you see, I'm considering T1 as 32 degree Fahrenheit and T2 is 75 degree Fahrenheit. This is the first condition, means increasing in heat. There is no confusion in this. And it's a heating process. So we are adding the heat so that the increase in temperature, and adding the heat means what? Enthalpy. So we'll talk about enthalpy also, but first point is you see temperature. Second
Just
point,
one question, sir.
yes.
How you showing that increasing the heating will be horizontal like this? Is there any lines representing the addition of heating?
You see, Here, increase in temperature means by adding the heat only, na? Okay, you
On
see.
that, we need to assume, right?
No, we have this enthalpy also. We'll discuss. Give me a minute. So you see RH. Now
This
let
is
me
no,
check
sir.
this.
20,
Yes.
20, 40, 80, this
Hmm.
100, this blue lines are, I think,
You
this
see,
was dew point.
this is 30. And going in straight means this 32. And this point is going to be what? This 80 is 70. So this can consider as 75, no? Okay.
So increasing temperature, that means addition of heating.
You
Yes,
see
sir.
the first point. Don't do the conclusion. Let me complete these points. Then you'll get the clear picture. So at this level, we are talking about the heating process. So I'm talking about only heating. And when you increase the temperature, means by adding the heat, so we'll verify what will affect to the other properties of air. That is our
Mhm.
aim to discuss this, so that you can understand change in one property will affect what will be affect to the other properties of air. So in this case, the process is what? Heating process, and it's a sensible heating. Sensible heating means we are not adding the moisture, just we are adding the heat, and that to sensible heat. So first parameter, you see temperature, we are increasing from 32 degree Fahrenheit to 75 degree Fahrenheit, because as per the example, you can take any two temperatures. This is just example. Now we'll inspect RH at this point, nothing but the relative humidity. This is interesting point. You see, at RH1 means this point is 1, so all this 1 means related to this condition in this point 1. So RH1, you can find, you see 40, this line is 60, and this is 80, so it's very close to 80, no?
Mhm.
Later after class with the scale you can measure, you'll get 75.8. Already I have this value, so I'm writing this, so you can verify with the scale. You see, this is 60, no? And this is 80, and this, if I draw the point, is very close to, you see, center line of this is 75, and this is above, slightly above 75, so I'm considering 75.8. Or using this two parameters, you can find out with the psychrometric software also, no? The other parameters that you can verify later. At this level, just focus on the heating process. Those values what I'm rating is extracted from that psychrometry only, using that software. Now what about RH? You see this point, so you see this line is 20, so less than 20, na?
Mhm.
So exactly, if you check, you'll get 15.6%. Now you can notice the very, very important point: increase in the temperature. But you see, decrease in what?
Relative humidity.
RH. Now with the RH, we'll check humidity. So you'll get the clear idea between the humidity and the relative humidity. Still, if you have confusion between humidity and relative humidity, now you'll get the clear idea. So W stands for humidity ratio, na? So do W1. You see W1 and W2. In psychrometric chart, this horizontal line represent what? Dew point temperature as well as humidity ratio, right? So this 20, 40, these are all humidity ratio. Okay. So you can find one more scale with the dew point temperature. At this level, I'm not bothered about the dew point temperature. So you can find this humidity ratio. So in this case, can I consider W1 equal to W2, which is what? Which is at 20,
Yes.
20 what? Grains per pound of dry air. And with this point, I can say this heating process is sensible heating, not the latent, because the humidity is not changing, no?
Mhm.
But what about this RH? If the humidity is same, how this RH will change? This point is important. You must understand. You must try to understand this. He's online. You see, humidity is same at point 1 as well as point 2. There is no addition of the moisture. Then, but the RH is decreasing now from point 1 to point 2. At point 1 is 75.8. At point 2 is 15.6. Very less compared with the point 1. So how it is happening? You see, this is interesting point to discuss.
When temperature is increases, I mean the
Mhm.
capacity of holding the moisture is, I think, increases.
Very good. This is the only point. Yes, you can please make a note of this point. As the temperature increases, the holding capacity of moisture by the air will increase. But you see, the humidity ratio is same, means per pound 20 grams only, but RH is reducing. It means at this temperature, 15.6 RH, it means the holding capacity increases. That's the reason RH decreases. Because as the temperature increases, the holding capacity of air, holding capacity of moisture by the air increases. So that's the reason this RH is decreasing. But practically per pound, the grains of moisture is same because we are not adding or removing the moisture. Na? So the total moisture or grains in the room is same. But the holding capacity increases. That's the reason the RH is changing. So I think you are getting the point, getting the difference between the humidity and humidity, this relative humidity. Clear
But
online?
sir, can you explain that how it is possible that temperature is increasing and the holding capacity that also increases?
For example, you see here at point 1, RH is 75%. Na?
Mhm.
At what? At 20 grains per pound of dry air, 75.8, say round off to 75%. It means at this temperature, at 32 degree Fahrenheit, we can add say 20. If I consider 75%, then what will be the remaining?
Maybe 25, I think.
Say for example 25. So
20.
when the humidity ratio increase to 25 grains per pound, it means RH will be 100%. Na?
Yes.
It means at this temperature, the maximum holding capacity is 25 grains only. But now if you check this 75 degree Fahrenheit, this 20 grains per pound is what? 15%. Assume just for round off, I'm considering say 10%. So 20 is a 10%, means further I can add how
Let's
much?
say 200 grains, something like
So it means just roughly say 200 grains per pound. If I maintain in this, for example, at this temperature, in that case, we can consider RH is going to be 100%. Getting a point? So the holding capacity increases with respect to, so RH is what? What will be the maximum possible at the saturation condition compared with the actual condition with this
Yes, yes,
process.
yes.
So now if you talk about the enthalpy, the heat, so you see H1 at this point, and you see this red color numbers represent the enthalpy. So H1, if you check with the psychrometric software, 11.6, and H2, I'm getting say 22 BTU per pound, and delta H is what? 10.4 BTU. It means in order to, so this is a key point. This is a capacity of the cooling coil. Sorry, my mistake. Capacity of the heating coil, so that one can increase the temperature from this 32 degree Fahrenheit to 75 degree Fahrenheit, okay, per pound of the air. So we are not talking about the total flow rate here, just we are considering for 1 pound. Okay, so this is the capacity of the heating coil at the initial stage. So if you add this 10.4 BTU to the air at the temperature of 32 degree Fahrenheit, it can increase to 75 degree Fahrenheit without increasing the moisture. Okay.
Without increasing the moisture.
Moisture means the humidity, because the humidity ratio is same. Na? RH will decrease because the holding capacity decrease means this already we discussed.
This is per pound of air, right?
Yes, this is per pound. You see 10.4 BTU per pound.
Okay.
So this is the heating process. So it means if you add the heat, that is a sensible heat, the temperature will increase and the humidity ratio is going to be constant. RH will reduce and RH will reduce and the humidity ratio is going to be constant. Okay, so this is only heating process. We are not
So, sir,
adding or removing the moisture. This is one process.
okay. So,
Okay.
just in my mind, one question is that
Mhm.
once we increase the temperature, I mean, relative humidity is decreases. That is
Mhm.
15.6%. At the same time, as per the design aspect, we need 50% of relative humidity.
Mhm.
So again, I think we need to, humidification is again required, right?
No, that's the reason I said, na. What we discuss is only heating process.
Okay,
We have
okay,
all this process, then we can do the conclusion.
okay.
You see, and one more reason why we are discussing this, because you see, different application, different requirement. So in some application, we require only heating. We don't require this humidification for a particular process control. That equipment or the machine not required to maintain the humidity, but a particular temperature.
Mhm,
That machine, suppose in Western country, and
mhm.
in that the temperature is very low and it will not perform efficiently. So we need to maintain or in increasing the temperature only. by adding heating. So this process can be used.
My question is that if it
Mhm.
increases the temperature like 75 degree Fahrenheit, so
Mhm.
relative humidity is 15.6%, right? But we discussed previous classes that for comfort design, we need relative humidity
No, no, you
50%.
see, just now what I said is a process control. So different process for different application. So just don't think for human comfort. We are dealing with all this process. At this level, don't do the conclusion.
Okay,
Just
fine. No
try
issue.
to understand the process so that this will be used at the time of load calculation as per the application requirement.
Okay.
For a particular application, suppose for a particular application means I'm talking about a process control. A room in means machine, a machine, for example, a CNC machine. Okay, in the Western country that is operated automatically, self-operated machine. So I need to maintain a particular temperature, and the area temperature is say less than this 75 degree Fahrenheit. Suppose the machine is in centigrade, for example, the machine requires 20 degrees centigrade, but the atmospheric temperature or the area temperature say 10 degrees or less than that. So in that case, we require only heating because the machine not required that humidity for that particular machine, because some machine required that humidity also because that release the heat. So that also one case, but a particular machine not required the humidity, so only heating is required, so we can use this process. So just try to understand the process of heating. That's it. When you add the heat, what will affect to the other parameters. So this
So,
will help you at the time of discussing the mix air, and the mix air concept is important. Refresh air and retain air. So step by step, all this process will discuss so that at the time of load calculation, based on the application, one can decide which process is required. According to
okay.
that, we can plot the parameter on psychometry first theoretically, then the same can use in a practical way. You see, the practical side of this 10.4 BTU per pound is a capacity for 1 pound. And if you know the total flow rate of air, we can find out the total heat. That will help you to find out the capacity of the heating coil. Okay, but at this level, this theoretical. We have some more points to discuss to get the, because flow rate is not added now. So we have an equation at the end. After all this process, we have sensible equation, we have latent equation, and we have a total equation.